Hey guys, it's Mr. Lowry. This is your lesson for Wednesday, January 13th. If you're in cohort A, if you're in cohort B, it's Thursday, January 14th. Today we're going to be talking about another method for solving systems of linear equations. We've already talked about two. We did graphing and we did substitution. This is our third one for today. So this is called elimination. So let's go ahead and start our notes here. And I'm just going to do them right on this piece of paper, and you can kind of mirror what I'm doing here. So we'll do 113 if you're cohort A. Again, if you're cohort B, it'll be the 14th. And we're going to do solving systems. We're talking about linear equations, but the method we're using here is called elimination. All right, I'm going to show you what that is in just a second. Before we get too far into that, we actually need to go back and talk about some properties of equality that we're going to use. So I'm going to go ahead and do my kind of Cornell style here. I'm going to draw a line down here. And our first key concept we're going to add are a couple properties of equality. Okay. Now we've talked about these before, but we're going to need them today, so we need to go back through and review them. Let's start with addition. Okay, so we're going to do the addition property of equality. Okay, now I'm going to give you a symbolic version, and then I'm going to give you an example. The symbolic version you're going to see from time to time. You'll probably see it next year as well. Don't get too hung up if it doesn't quite make sense. I think the example will make more sense. But here's the idea. When you have the addition property of equality, it usually looks something like this when it's written in a textbook. If A equals B, then A plus C equals B plus C. All right, so I know that looks a little bit weird, but essentially what you're doing is you're starting with an equation that's true, and you're saying you're allowed to add anything to both sides as long as you add the same thing to both sides. Right? So if you have an equation and you added a third thing, right, you could add C to this side and add C to this side, and you would still have a true statement. Okay? So this is kind of how the property looks in symbol form. Now let's take a look and see how we would do this in kind of in an actual equation. All right, so let's say we were solving an equation and we had x minus 10 equals 15. Okay, we'll do this as kind of an example. What we know here is that we're allowed to do this. We can add 10 to this side and add 10 to this side. As long as we add the same number to both sides, then the equation is staying equal. The reason why we did 10 here is because we want to undo this operation. Okay, and then we're going to get x equals 25. Okay, so that's called the addition property of equality. We can add the same thing to both sides of an equation, and we're still going to get a true equation. Okay. That's an important property. Okay, let me give you another one here. The next one is the multiplication property of equality. And I'm just using some abbreviations here, which you're welcome to do too. So multiplication property of equality. Okay, now again I'm going to give it to you in kind of like symbol form, and then we'll use an actual example. So this is how it goes. If A equals B, then AC equals BC. Okay, so think about it. I start with an equation like this, and I multiply both sides by C. If I multiply by C on the left, I'll get A times C, or AC. And if I multiply by C on the right, I'll get B times C, or BC. Okay, so these are equivalent equations. Right? If I take a true statement and I multiply both sides by the same thing, I get another true statement. All right, let me give you an example of how that's going to look when you're like solving an equation. Okay, so if I had like x over 5 equals 11, right? Well, I'd want to get rid of that 5 in the denominator. Okay, and so I'd want to do the inverse operation of divide by 5, which would be to multiply by 5. So I would want to multiply this side by 5. But in order to keep everything equal, I have to multiply this side by 5 as well. So as long as I multiply both sides of the equation by the same number, then my equation is still true. I get another true equation. So these will cancel. I'm going to get x equals 55. I can be sure that this equation is true because I multiplied both sides by the same number. Okay, so those are two properties of equality we're going to use today, the addition property of equality and the multiplication property of equality. And you'll probably see these again kind of in this form, probably in SM2 and maybe even in SM3 and beyond. Okay, next we're going to actually talk about solving systems, because that's the whole point, right? We're solving systems of equations. So let's talk about what elimination actually means. Okay, so we're going to use addition prop of equality to eliminate a variable. Okay, so we're going to use one of these properties of equality. Let me give you a system really quick, and I'll show you how we're going to do this. Okay, so here's a system of equations for you. 10x plus y equals 15, and 4x minus y equals 13. Okay, so here we have a system. And notice that these are both in standard form. They're not in slope-intercept form, but that's okay. Standard form's fine. Okay, now let's just take just the top equation for just a second, and let's just analyze it for real quick, okay? So we have an equation here. Now, if we wanted to, we could add the same number to both sides. We could add 3 on this side and 3 on this side, or really whatever we want, right? Okay, so check it out. What if I added 13 over here and I added 13 over here, right? Would that be legal? Sure, it would be totally legal because I'm adding the same number to both sides. Okay. Now, of course, there's not a like term here to go with 13, but that's okay. As long as I add the same number on both sides, I'm going to get a true statement. So that's the addition property of equality. Okay. Now, if you think about it for a second, 13 we know is equal to this amount. So if I take that first equation and instead of adding 13 right here, I added 4x minus y, would that still be true? Now let me rewrite it because that's got a little cramped, okay? So here's my first equation. What if I added 13 here, but instead on the other side, instead of adding 13, I added 4x minus y? Would I still get a balanced equation? The answer is yes, because if you look at my second equation, 13 is equal to this whole thing. So adding 13 on this side, on the right-hand side, and adding 4x minus y on the left side, I'm really adding the same thing to both sides because I know that these are equal to each other. Okay, so really this is the addition property of equality. I'm adding the same value on both sides of the top equation. So taking the left side and adding something, taking the right side and adding something, and those things are equal to each other. And so it's legal. Okay, let me show you what's going to happen when we end up doing that. I'm going to write it one more time here, but this time I'm just going to kind of leave it like we had it in the beginning. Okay, so what you can do, what you're allowed to do here, is you're allowed to take a true statement, an equation, and you can add to that another equation, and you're going to get a third equation. That's true. Okay, so you can just add these two equations together. So check out what happens when we do that. Okay, 10x plus 4x will be 14x. Okay, we have y plus negative y. Well, that's actually going to give you 0 or 0y. Okay, so these actually go away because we get 0 there. And then we get 15 plus 13 equals 28. Okay, and this is a true statement. So think about what just happened there. We added two true statements to get a third true statement, but what's special about this guy? It doesn't have any y's in it, right? All the y variables are gone. We call that elimination. Okay, so we use the addition property of equality to eliminate one of the variables. If we have equations with two variables, we can't really get that much farther until we solve for one of the variables. Okay, so this is called elimination. Now from here, we can just solve this like a regular old equation with one variable, divide both sides by 14, and we get x equals 2. Okay, now that's not our solution yet. Okay, if you think about this, this is a system, right? We talked about systems of equations. What does a solution to a system look like? It looks like an ordered pair, right? It looks like an intersection point. If we wanted to, we could graph these two equations and we could find where they intersect, and it would be a point. So, we're not done yet. We have half of our solution. How do we find the next part? Okay, well actually this part is no different than elimination, or excuse me, substitution, our other method. So we've actually already done the elimination part. The rest of it is just substitution. So what I need to do is I need to take this value and I need to plug it into one of these two equations. Okay, doesn't matter which one. Let's just take the top one. Okay, so 10x, or 10 times 2, plus y equals 15. Okay, I'm taking this number and I'm plugging it into the top equation. So 20 plus y equals 15. Okay, if I subtract 20 from both sides, I get y equals negative 5. Okay, and there's your solution. Alright, so elimination is when one of the variables goes away, and in order to make that happen, we use the addition property of equality. Okay, let's do another example, and then I'm going to let you guys practice. Okay, so we'll do our second page here. We're going to solve a system with elimination. Okay. Now remember that when we use elimination, it's really the addition property of equality that we're using. Okay. So let me give you a system here. So we'll do 6x minus 4y equals 24, and negative 6x minus 7y equals 9. Okay, so all we're going to do here is we're going to draw a line under these, and we're just going to add these two equations together. Okay, so we got 6x plus negative 6x. Well, that's 0, right? So I get 0 x's. I don't even have to write that. Okay, that eliminates the x's. Okay, I got a negative 4y and a negative 7y. That's negative 11y. Okay, and then I have a 24 plus a 9, which is 33. Okay, so that's the elimination step. I'm adding two equations together. That's really the addition property of equality. When I get rid of a variable, that's called elimination, and now I can just solve for y. Okay, now in the previous problem, we eliminated y, excuse me, and solved for x. In this case, we eliminated x. We're going to solve for y. It doesn't really matter. Okay, so let's divide both sides by negative 11. So y equals negative 3. Okay, so are we done? Nope, we only have half of our solution. So how do we find the other piece? Well, now that the elimination part is done, that stage, we're going to use substitution here. So I can pick either of the two equations we have left over, or from the beginning, doesn't really matter which, and we're going to plug in that value. So let's just do let's do the bottom one this time. All right, so there's the bottom equation. If I plug in a negative 3, I have negative 6x minus 7 times negative 3 equals 9. Okay, so negative 6x plus 21, right? If I multiply a negative 7 and a negative 3, I'm going to get a positive 21. Okay, we'll subtract 21 from both sides. That's going to give us 12. Excuse me, negative 12. Okay, and then we're going to divide both sides by negative 6. So x equals 2. All right. So there's our full solution. All right, so there's 3 steps, okay? You start by adding the two equations together to eliminate a variable. And then you take that number, you plug it back into one of the equations, and then you do that substitution to get the other variable. So that kind of sounds like 2 steps, but there's one more step you might have to do to get something to eliminate, which we'll talk about in a minute. For now, let me give you a practice problem that you can do. So you'll kind of pause the video here and then and practice. So here's your practice problem. I'm going to do, try to pick a good one here for you. Let's do 9x minus 4y equals 6, and negative 10x plus 4y equals negative 4. Okay, so write that down in your notes. Okay, make sure you got it right. And I want you to try to solve this with elimination. So you're going to start by drawing a line under here. You're going to add the column straight down. That should get rid of one of your variables. Solve for the other variable, and then use substitution. So go ahead and pause the video now and give that a try. After you've maybe tried that for 2 or 3 minutes, compare with each other and see what you got. And then if when you're all done, we'll turn the video back on. Okay, so you should have solved this system here and compared with your row buddies to make sure you have the right answer. Let's go through it real quick and make sure you did it right. Okay, so 9x plus negative 10x is going to be negative 1x, or negative x. Okay, 4y plus negative 4y is actually 0y, so we actually don't write the 0y part, we just kind of cross that out. Okay, and then we get 2 here. 6 plus negative 4 is 2, or 6 minus 4, however you want to think about it. We're basically just combining here. Since if you want to think about it as 9x minus 10x, that's fine. It's the same as 9x plus negative 10x. It's either way. You're just combining the like terms. Okay, so the last thing here is we need to divide both sides by negative 1 because we have to get rid of that negative. If you think about it, really this is negative 1x. Okay, so divide both sides by negative 1, you get x equals negative 2. All right, so that's not our solution. That's half of our solution. Okay, the next thing we need to do is take this and substitute back into one of those equations. Okay, so let's use the first one. 9 times negative 2 minus 4y equals 6. Okay, this is the top one. Just plugged in a negative 2 here. Remember to substitute into parentheses. Okay, so negative 18 minus 4y equals 6. So we'll add 18 on both sides. Negative 4y equals 24. And divide both sides by negative 4. And you're going to get y equals negative 6. Okay, now you have your full solution. Okay. All right, now what you might be thinking to yourself right now is, does this always work every single time? The problems that I've given you so far were set up really, really conveniently to make elimination work. So if you think about it, you got a 6x and a negative 6x, right? Or a 4y and a negative 4y. Or in the first one that I gave you, we had, I think it was a y and a negative y. So everything I've given you so far was set up to work with elimination. So the question is well, what if that's not the case? Okay, so let's do the next here, next key concept. Now we're just going to keep kind of adding levels of difficulty. So this isn't really any new concept. It's just going to require a couple extra steps. So let me give you another key concept here. We're going to add a piece. So we're going to do elimination where multiplication is required. Okay, elimination where multiplication is required. All right, so let me give you another system here. Okay, now if you think about it, if we were to just add these two together, we wouldn't actually have an elimination happening. So if I did 10x plus negative 5x, that would be a 5x. Y and negative 3y is negative 2y, and then negative 3 and 9 together is going to give you a 6. So if I just added those together right off the bat, I didn't eliminate any variables. I still have an x and a y, so that's not going to work. Okay. The goal here is to get an elimination happening. So what we could do is if we had like a 10x and a negative 10x, that would work. Okay? Or if I had like a 3y and a negative 3y, that would work. That would like cross out and give me the elimination that I want. So what we have to do is we have to force one of these equations to have an elimination that works. So let's think about this. How could we get this number here to be negative 10? So it would cancel with that. And we want to make sure that we keep the equation true still. The answer here is to multiply by 2. If I multiplied this number by 2, I'd have a negative 10. But in order to keep everything even, I'm going to multiply everything by 2. So if you remember at the very beginning of the class here, we talked about the multiplication property of equality. Okay, and now we're going to use that. So what I'm going to do is I'm going to take that second equation and I'm going to multiply both sides by 2. Okay, why 2, you ask? Well, again, the goal is to get, if this is 10x, I want negative 10x here. Right? I want something that's going to eliminate. Now the rest of it we can't really control. We're really only trying to change this number, but in order to keep it even, that's why we have to multiply everything else. Okay, let's see what we get. So our first equation hasn't changed yet. Okay, that's the same. But now my second equation is going to be negative 10x minus 6y equals 18, because I have to distribute, right? So 2 times negative 5 is negative 10, 2 times negative 3 is negative 6, 2 times 9 is 18. So with just a quick move here, I've now forced it into something that's going to eliminate, right? So now when I add these together, these go away. I get, for the y's, negative 5y, and then over here I get a 15. Okay, so now it's going to work. I have to force it to eliminate. I have to use the multiplication property of equality to make that happen. So we just remember that this is the multiplication property of equality here. I'm allowed to multiply both sides of an equation by the same number. Okay, now from here it's just the same. So divide both sides by negative 5, so y equals negative 3. Okay, I just got half of my solution. In order to get the other one, I need to plug this back in. Now I can plug it in here or here. Now I also have a third equation that would work, so you're also welcome to use that one. It doesn't really matter. So 10x plus y, but instead of a y, we're going to do a negative 3. So I'm actually just using the top one here. So 10x and then if I add 3 to both sides, we'll get 10x equals 0. That's kind of weird, but we can actually keep going here. Don't necessarily freak out just because you get a 0. Okay, divide both sides by 10. Okay, you can do 0 divided by 10. It's just 0. Okay, so I get x equals 0. All right, so sometimes you get zeros, and that's okay. 0 divided by 10 works, right? You can do that. So my solution here is x equals 0. Or 0, negative 3. Okay, so sometimes you have to multiply. Now let's assume for a second that we wanted to eliminate a different variable. Let's do the same problem, okay, but this time let's eliminate the y's. So you actually get to make some choices here, okay? Instead of trying to eliminate the x's, I can do the same problem a different way, and I can multiply the top by 3, right? The goal was to get something to eliminate. So if I had 3y and a negative 3y, that would work as well. So instead, let's try this. Let's multiply the top equation by 3 everywhere, okay? Because then I'll get a 3y on top. So that my top equation will be 30x plus 3y equals negative 9. And on the bottom, I'll have negative 5x minus 3y equals 9. Okay. When I put these two together, I get 25x. Notice now the y's eliminate. I just set it up so this gives me 0. Okay, and then these give me 0 as well, and that's okay. You can it's okay if those give you 0. Divide both sides by 25. Okay, 0 divided by 25 is 0, so x equals 0. So notice I got the same x. If I plug this back in, I should get that same y. So essentially we kind of did the same equation, we just did it twice so you could see that it actually works both ways. Okay, so let me give you another one here, and then you can kind of practice. So same key concept, we're just practicing examples where we have to multiply one of the equations. Let's try this one. So we got 2x plus 4y equals 4, and then negative x plus 4y equals negative 26. Okay. Now there's two options here. You got to kind of use your imagination here. If we had 2x and negative 2x, that would work. We could eliminate that way. Or if we had 4y and negative 4y, or something like that, that would work. Okay. So you could either multiply one of these equations by negative 1 to get the y's to eliminate, or you could multiply the bottom one by 2 to get the x's to eliminate. Okay, so we're going to try to make this happen. We want that guy to be a minus 2x, not a minus x. All right, so let me help you set it up, and then you guys can practice from there. So we got 2x plus 4y equals 4, the top equation. Okay, what I'm going to do is I'm going to multiply both sides of the bottom equation by 2. That should give me negative 2x plus 8y equals negative, let's see, negative 52. Okay? All right, now I want you to go from there. So go ahead and pause it now and finish up the problem. Okay, coming back from pause. So we're going to just add kind of down the columns here. 2x and negative 2x is 0x, but we don't write 0x, we just leave it blank. Okay, 4y and 8y is 12y, and then we add these two together, we get negative 48. Okay, divide both sides by 12, and you get y equals negative 4. All right, not our final solution, but half of it. Okay, so how do we get the rest of it? We got to take this and plug it back in one of those two equations. So either this one, or actually this one would work as well. They're all true equations. Let's use the top one. I usually pick the one that's, the easiest to use, it has the smallest numbers, that kind of thing. So 2x minus 16 equals 4. I just plugged in y right here, negative 4. Okay, if I add 16 to both sides, I get 2x equals 20. Divide both sides by 2, and I get x equals 10. Okay, cool. All right, let me give you another one to try. And so whenever you pause the video here, what I would do is I would probably spend 2 to 3 minutes working on this on your own. And after 2 or 3 minutes, then compare with the people in your row, talk it out, see if you can help each other out, correct each other's problems, maybe fix any misconceptions you might have, work together, and then when you unpause the video, you can go back and just verify your solution. Okay, so let me give you another example here, and you can keep practicing. Let's do, all right, 2x plus 7y equals 30. Negative 4x minus 6y equals negative 12. Okay, so I want you guys to do this one on your own. Think about how you're going to get things to eliminate. Okay, maybe give yourselves, like I said, 3 minutes or so to work on it on your own, and then come back and work together on it, and then unpause. Okay, so coming back from the pause here, we have to get something to eliminate. Okay, you can eliminate the y's, you can eliminate the x's, it doesn't really matter. In this case, it's going to be the easiest to eliminate the x's. Okay, so I can get this thing to be 4x. right? I have a negative 4x here. I want a 4x here. So all I got to do is multiply the top one by 2. So I'm going to multiply every piece on the top by 2, multiply both sides by 2, but really we're going to distribute the 2 on the left. So every single piece gets multiplied by 2. That's going to give me 4x plus 14y equals 60. And on the bottom, that one hasn't changed. Okay, now add or combine the x's, combine the y's, combine the numbers. So this is gone, 0x. You don't have to write 0x, it's just 0. Okay. Here we're going to get 8y, and then here we're going to get, looks like negative 48. So kind of similar to the last one. Okay, divide both sides by 8, and we're going to get y equals negative 6. Not our solution, but half of it. So to get the other half, we got to plug back in. We can plug it in the top equation, the original, or we can plug it in the bottom equation, or we can plug it in this new equation that we got. I'm going to use the original top equation. So 2x plus 7y, 7 times negative 6, equals 30. Okay, notice I'm using the original before I multiplied it by 2. Alright, so 2x minus 42 equals 30. Okay, I'm going to, that'll seem a little bit big to me. Plus. Just double check this before we go on too far here. 4, 14, 6, make sure I wrote it down right. Okay, let me just keep going and see what happens. Starting to think I might have made a mistake here, but we'll see. If you guys can catch my mistake, then bonus points. Alright, so if I add 42 to both sides, I should get 2x equals 72. X equals 36. That seems a little bit big. Something went wrong here. Negative 6. Hold on, we got to find our error here. So 2x, so it's 4. Make sure I wrote the problem down right. Negative, negative. Okay, that's going to be gone. Negative. Okay, let's scrap that one. I did something wrong. The solution is supposed to be negative 6, 6. So I got a negative messed up somewhere along the line. So hopefully that didn't throw you off. And sorry if it did here. But this should be the solution. Okay. Now, right now you're probably almost out of time. So if you need more examples, I'm going to do some more examples on your homework. Your homework for tonight will be in Canvas, but or posted in Canvas, but it's actually going to be some problems from your textbook here. So we got page 233. You're going to do that, and you're going to do problems 3 through 20 and 22. Okay, and I'll make a homework video, like I said, to kind of help you get started with some more example problems. If you guys can troubleshoot that last problem and figure out what went wrong, that would be awesome. And I'll maybe post something if I can figure out where the error is. Somehow a negative got lost along the way. So go ahead and get started here on your homework. And if you get stuck, like I said, you can help each other out or check out a video in Canvas. Thanks.